It's a new day, and I got my chocolate brown coffee. I love caffeine. Coffee, on the other hand, not so much. Alright, so as you know, yesterday I accomplished quite a bit. I did manage to get all the hardware done and get the printer all hooked up and connected, and I rewired and redid all the extruder motor deal here. Don't know if that's going to be helpful yet, but yeah, so one step at a time here. I'm slowly figuring out how to do stuff, and I didn't do anything since yesterday. But if I let's see, if I connect, oh, it's probably connected. Guess I have to plug it in. So I've still got my USB port up front here, which just goes back to a cord that's plugged into the Arduino. So today I'm going to show you a little bit more about the software on the upgraded Delta version here that I'm modifying. So I currently took the original files, the firmware I should say. If you want to learn more about the firmware, please watch my older videos. There's a particular video of me building my Rostock. You're going to need to go through that and actually watch towards the end, around 43 minutes I think, there's software. But currently I'm just going to show you how I edited the configuration H file. So I went and grabbed the new firmware off of GitHub, I believe is the location, and I'll link you guys the description. In the description, I will link you back to the place of where I got all this stuff. So here's the deal. I grabbed the new firmware, and I took the old firmware that I originally put on my printer, and I relabeled the folder so that it just had configuration h.old and then configuration advanced.h.old. And then the other things is the new files. So these are just the standard files. This is how I was able to keep both of them isolated, so I knew which one was which. So this program I'm using currently is called Notepad++. And so if you get Notepad++, you can get a plugin, and it's called Compare. This will make your life a lot easier. So pick a file you want to compare, hit compare, and this is what will show up. So right now I'm comparing configuration H to configuration advanced, so that's not good. So I'm going to select on, so the files are the same, hit compare, and now I'm comparing the old one over here. This is the old one, this is the new one. And this program is pretty nice. It gives you the options over here, color codes everything, so you can see what's different. It will even link the two together so that when you scroll, it found everything that's the same, it matches up, so you can see exactly what's what. So you can, this plus button, this green, means that this bar is added or extra over here, and it's not over here. Anything that's in red is things that is not the same, so that's really nice to determine what's different. And the yellowish color here is saying that there's some issues, some differences. So this is actually telling you there's something different between these lines. The red is that you don't have the same thing at all over here. So what I did, for instance, is this is my new file. So I went down this file and I found out what was here and what was over here, and I just changed it so it equaled the old version that I had. So you just scroll down through here, and you do that to all the settings. Stuff that's brand new, like all this stuff is brand new, it's not in this old version whatsoever. You just need to read through this carefully and make sure it's something that doesn't that you didn't need to change. Most of that stuff I actually didn't need to change at all. Some of the stuff I did, I had to pay attention to it, but really I just went down through here. See, like this line is just a comment. It doesn't even, it's not, it's something that's just added, so it's not a huge, ordeal. You'll find out sometimes, occasionally, this doesn't line everything up perfectly, but for the most part it does a really good job of lining everything up. So go down through all of these things. Make sure you know exactly what you have. Make sure you check, double check, triple check, and then go back to the configuration H. You're going to go to the plugins, clear results. Click on the configuration H, compare, and so let's see, old and new. Alright, so same thing. You're going to do each file. Make sure that you go down through here and double check that everything is the same. They're always updating. It's open source, so everybody's always adding and updating to the firmware. That's why there's so many new and different things that aren't, it's not even over here in the old configurations at all. So it's important to know your printer pretty well so you can go through and edit everything. So that's really the basics of it. I would like to show you, I didn't want to close. Let's clear results. So let's go to the new configuration. All right, and you want to go under here under the delta settings. And in the delta settings, again, you have your length, your diagonal rod, your smooth offsets, your end effector offsets, your carriage offsets. All of this stuff should be relatively exactly the same as what your old version is. And then down here you start getting to the auto cal, which is what I was looking for. All of this auto cal information is very important. You need to know what you're looking at. So you've got the auto cal travel speed of when it's not probing, the speed at which it is probing. I played with both of these and I recommend just leave them alone. It was very comfortable in the speeds on my Delta. Faster is less accurate, and slower is just slow. It takes forever to do an auto calibration. Auto cal probe lift, this is how high you want it to lift the probe between moves and between checking. Actually, I think it's just between each time it probes. Sometimes it probes more than once, so you need to remember, that's going to take a lot of time if you're probing a lot. Everything seems to be pretty well set nicely. I haven't messed with that. The precision, this is auto cal precision. It is important. I could not get my printer to calibrate any less than like 0.075, which is plus or minus like 0.03 something. So I recommend, if it doesn't work, it doesn't auto calibrate, bump this number up a tiny bit at a time, because for some reason mine just would not auto cal. Now there are two versions. There's a Marlin development, and this is the development version. That's what I'm playing with right here. I could not get this version to work correctly. I liked it better when it did the auto cal, but there's something wrong with my setup and or the firmware currently, because it's not a finished version. So I actually ended up using 4.1 or 1.0.4, I should say, and you can find it in the same place. Again, I'll link in the description where you can find some of this stuff. So, diameter of print bed. This number basically is how round or how far out do you want your probe to go. So if you set this number really low, it's only going to probe a tiny little area. I figured out I had to get it to the maximum potential. I really wanted this number to be as high as possible in order to get all the way out to the edge of the bed. That made a very beneficial, because it didn't probe the corners and it's just probing the center. Then that's not going to be helpful either. So these numbers, don't mess with these. As far as I'm concerned, I haven't messed with any of those. Now these I did play with a lot. These are the probe variables. If you have an automatic probe deployment system, then you're going to want to set all these values, deployment start and end location. So basically you can make the print head move to a particular point and hit a pin or whatever the case may be. Some people are using servos to lower their probe. If you're using a magnetic one that is magnetically held in place, you can put a slider on there and you can make this move in the right spot. Hit that slider and drop it automatically. Now I thought that I need to be probing every single time I print, but that's not the case. You only probe when you modify or set up a new piece of glass or something like that, and then after that you just trust that it's level. So you only really need to probe that original first time. So all these numbers, this is the X, Y, Z, and E. You normally don't mess with the E's, that's why they're all zeros here. The first numbers, this is your X, Y, and Z offsets. So the first number, this is very important. You need to set this right or your auto cal isn't going to work right. You need to actually measure from your probe to your hot end the distance and then punch those numbers in here.
You can do that by actually setting the printer up, and actually running the probe down until it hits the limit switch, and then bringing it up until the probe lifts off the glass. And that is, well, actually you should put the probe out, deploy it, run it down manually with the Printer face or some other interface, and run it down to where you turn on your sensor, check the value on your screen, it'll tell you, and then at least it does on my LCD screens what I'm using. So after you do that, you got to bring it down to the point where the print head is just barely, touching the glass, and that's the number for your, your Z offset here. That's this number. And then your Y is the same way. Set up a point on your glass, and then move the probe around manually till you get to where the probe and the print head is located in the same spot, and figure out exactly what you moved and punch that number in here. So X and the Y offset, this all has to be right, or your auto cal isn't going to punch in the right numbers when you try to save it. If your height is off, for sure, that's going to screw you up. And so then the same thing here, your start and your end location, that's where it's the print head is moving in a fashion of which you'd like it to. I actually put all these at I tried to put 0 in all these because I didn't want it to go anywhere to set. I wanted it to go right in the center and start probing. And so I put 0, 0, 0, and I couldn't get it to work. I finally had to just put a 1 in all these. It would not accept 0. You could put a -1, you could put a 0.01, you could do anything, but for some reason it wouldn't accept 0. That really threw me off for a while, but I finally figured it out. And then your retract location, if there's a particular point, or if you have like a stud sticking up that you want to retract the probe, that's what these are. This is your start and stop location. I just pretty much put all these at like a 0 point almost. I don't actually have my particular one open. And then the auto, the grid, the auto level grid, this is the distance between the auto level Z probe points. It should be less than the print surface radius divided by 3. I actually change this number all the time, and it didn't really seem to affect anything. And I'm using delta, and I'm not sure if the delta configuration is different than the standard XYZ. So I haven't got this number to really affect anything, or that I could visually see. So I just kind of left it alone. And other than that, that's really the main important part of the new functionality, is the auto calibration. Everything from here down. You really need to read through this, play with it, figure it out, understand it. If you don't, you're going to be just confused for a while. So the rest of the stuff was just a comparison between the two files, and then this is your other important part, is the new AutoCal function. So let's get to actually like showing you what the AutoCal looks like, and show you what some of the functions look like on the screen. So we'll see if we can do that. Woohoo! Alright, so we just went over the software, and now I'm going to show you a little bit of the actual software in action, and how the auto calibration is supposed to function, what it's supposed to do, and how it works. So I'm currently loading up some files here, Printer face, and once we're up and loaded, I will show you exactly what we're doing. Alright, so we're all connected. We've got Printer face pulled up here, and I'm currently going to type in a G28, and that homes this thing. Now, I actually took the probe out because there's no need to have it in there. Oh, where are we at? There we go. Make sure it floats freely. Sometimes it gets stuck. Seems to be okay. So we pulled the probe down. Now what we're going to do, we can do an M666 space L, and it will actually give us all of the information here. Let's see if we can focus. It's actually better if I zoom. So we can get all the information here of the delta configuration as it currently is right now. So currently you can see our in-stop offsets are adjusted. Z probe, that's the actual dimensions that I punched in manually, which you can actually change on the fly by entering an M66 space the letter off to the left, and then enter the value, and you can actually change it. So let me actually give you an example. So if I do M666, which one? Let's see.
Alright, we're going to do J tower offset is 0.5. So if I put M666J space point, or let's just do 1, and I hit send, it says sending. Now I'm going to do M6, oh, type it in, M66 space L. Look, changed. So you can actually change these values on the fly. So I'm going to put it back. I'm going to say J is 0.5. Alright, now if I do a L. Alright, so we're changed back to where we want to be. But you can actually punch these in manually, so you can adjust the height without ever reloading the firmware. What an amazing option. You can also, on my current settings here, I can go in here and hit Control, and I can store and load memory. And you have to actually store and load the settings, because if you turn it off, the settings will go back to default. And if you restore failsafe, that's the factory, settings you punched in manually. The load memory is the ones that you stored. So these two work hand in hand. This one's the original numbers you punched in from the original firmware. Keep that in mind, because I got confused. So, in order to do an AutoCal check, we're going to type in a G30. Now, make sure that your probe is sticking out if you have to do it manually. So I'm going to show you what it does. I'll get you by here so you can see it. Alright, so I put in G30, hit enter. It's going to home, and you can't see that. It's going to come down. It's going to probe all the way around. And it will retract the probe automatically. And there you go. AutoCal is done. Now the information that shows up on your screen is fairly important. Let me get the camera set up here so I can do this without moving the camera around. Alright. Sorry about the discoloration there. So, if you look here, the points that it probed are laid out exactly as you saw them get probed. So it started in the center, it went back here, and it went all the way around the outside. These are actually the offset numbers that I'm currently reading. Now, I haven't been able to auto-calibrate this thing very well at all, but this is how you would do it. It also has all the in-stop offsets and everything else over here, okay? Now, if you do, I'm going to do a G28. It's going to home the printer. Okay. Now, if we type in a G29A, this is when it's going to do its auto-calibration. Okay, so by punching in the A, it will do its auto-calibration, and I will show you. First, you want to load the defaults. So actually, let's do that first. I'm not going to actually load the defaults, but they recommend you load defaults, which in my case is a M502. Defaults loaded, and then do an M500. Okay, settings stored, M666 space L. It's going to give you, and it zeroed everything out. Alright, so everything's back to 0 except for, of course, the number that you punch in manually. And so now, what we're going to do is we're going to say G30A, and it's going to start its auto-calibration. Now I'm going to show you what the probe is going to do, and then I'll show you what the software is showing us. Okay, now it's going to go back and it's going to home. Alright, it has detected the surface, and these are the values that it gave us. And here it says adjusting Z height. Our original Z height was 156.2 and it adjusted it to 153.6. Okay, it's trying to get that as close as possible because it's saying it's off this much. No changes here yet. It's just checking, looks like to be just checking Z height right now. So it probed. Now it says it's adjusting the end stops according to these numbers right here. Is what it looks like it's doing. Again, we're just doing this repetitively. Checking its end stops and checking again. And it will constantly do this until it adjusts itself into place. Now, it will actually adjust the delta radius and the diagonal rod and the tower position adjustments and the end stop offsets. It will constantly run this program. I have found it to run up to 99 times. As you can see here, it's on number 3. So if you look, we started here at like 10 off, and now we're relatively down to, you know, pretty close approximations. And so I'm going to let this run. I'm actually going to leave this on the screen. And I'm going to film the entire process here, and so you can actually watch what the adjustments that it makes constantly. Okay, so it says calibration complete. Use an M500 command to save. So I'm going to actually do that because I completely removed what I was doing. So you can see it adjusted. Well, we can do an M600L. Oh, 666. Sorry. There we go. And get our measurements and differences in calibrations. So beforehand, actually, this was all calibrated a little different. Those numbers look fairly similar. Those numbers are definitely different. The diagonal length and the height offset are definitely different. The delta radius is different. So it seems that every time I do this, things are actually a little different. So what I'm going to do is actually check this thing. So let's do a G28, and it automatically retracted the probe, by the way. So on the printer face, I have the option to, you know, kind of move around the printer, so we can click these and actually move the printer around if you have never seen that before. But I'm going to go down until we get close to the glass. Now I think that my offset is actually wrong. So I'm going to move it down a little at a time until we see where we're at. Oh, looks pretty good actually. So I don't know if we can get that. Basically the Z offset is right here. So if I move it up 0.1, it will actually move it up 0.1. So let's move it down. Now it's back at 0. So 0, 0, 0, 0 on X, Y, and Z. So what we're going to do is kind of move it around the glass a little.
See if it looks fairly flat. That actually looks really good. It's getting a little close on that corner. There, I think it's actually possibly hitting the glass. No, it's off the glass. So, now what I'm actually going to do is print from the card, and I have this particular program that I created that is just an X. And let's see if I can find it. And we're going to print that. So I'll start recording once I start printing. Alright, here we go again. So what I've designed again here is basically this goes around the perimeter and then runs a X pattern, so that you're going to check the center of the bed out to the edge of the bed and around the edge of the bed. Now this is not the maximum potential that I can print, but it's pretty much the maximum that I usually want to print. I usually don't ever go past this. Okay, so here's what I could do. I could do one of two things. I could let this finish and show you what the print looks like. See if you can actually see this. It's not going to focus where I want it, probably. Well, that's okay. If you look over here, you can see that there you go. You can see the filament is not together at all. There's actually gaps and spaces. And you can see it off the back reflection really nicely, actually. But if you come over here, the opposite is occurring. You have a nice, even, complete print, and that's what you want. So by doing this X bed test, I can see if the center is centered versus the corners. So if there's any delta problems, I can see it. And then the other options, I could actually adjust the end stops manually, which I'm not going to do. Or I can adjust the bed via the screw adjustments that I have here. Or I have triangulation screw points. I have 3 points on the bottom and then 4 across the bed. And I actually have to use both to get this thing leveled for some reason. So I could pause the print and adjust it while it's running. And that would allow me to actually see what it looks like as it's running, which is really the best option I've learned. So what I'm going to do is it's actually almost done. It's got one more trace here, and I'll stop it and home it, adjust some stuff, and then I'll adjust it as it's running. So you just can't see it very well. That glass makes it hard, huh? There we go. So you can see what I'm talking about. If you come over here in this corner's going to look like really good. I won't focus, I know. Glass. Anyway. Yeah, well, no big deal. Alright, so I'm going to pop this off of here and do it again while it's running. Alrighty. So I did the test again, and I'm going to pull this off. You can see none of it's even sticking. I didn't quite let it finish this time. But
you can see this was last time's corner. This is the same corner, and now you can see I'm actually getting good good print there. And the last layer I didn't let finish, otherwise that would be solid. So the center is still a little bit up, and this edge is flat, this edge is flat, and this edge is pretty flat. So that tells me the delta configuration needs a little bit more calibration. Basically what it is by adjusting the delta length of the rods, you can actually create an imaginary cone in the middle, and you can either pull it up or push it down. So right now I need to push it down, which means I believe I need to make the arms longer, and that will push that down. And then also I ran out of threads on the back side here, so this corner is actually loose. I only have so much, so I can get it. I only have so much thread back there, and I'm maxed out. I either need to put longer bolts in there or do something slightly different. So anyway, so that's it. I'm just going to keep playing with the AutoCal until I get this to where it's flat all the way around. And once I get that, I'll film it so you can see what it looks like. Alrighty guys, so I just ran this another time. Did some calibrations, did some checking. I actually, like I said, I have a 3-point mounting system on the very bottom. So one there, one back there, and one there. And then I have a 4-point mounting system above that. So I can level per axis, if you will. So if the homing over here, if I want to move it, I just move the point over here, and it kind of brings this whole bed up. You can also do that with the limit switch offset settings, which I was showing you guys earlier. So here's what it looks like. I'm going to peel it off and give you guys a better view because it's hard to see on that glass. And we need to make one more minor adjustment, maybe on this corner, but everything else seems to look okay. Alright, so if we look close here, we can see that each piece, including the center, looks fairly flat. You can see this is actually very, very thin on this corner. See how thin it is? But it's real thick right here. So how do you explain that? Well, I believe that the printer, when it moves from like left to right, it actually very ever so slightly has a small difference. So sometimes that's hard to get rid of. Here that looks like there's more plastic in the middle. That could be just with the width of the type of settings that I have. This looks good, that looks good. If you hold it up into the light, you can see how thin, you know, this is versus the rest of it here. It looks good. If you look at the bottom, you can see that all the edges look really nice. No gaps in there. Oh, I was going to have to focus out. So anyway, that actually looks very, very good. I'm going to make a minor adjustment to this corner, test it again, but I'm going to call that done. So that is basically how I've been actually leveling my bed, and it seems to be working okay. The settings I ended up with, let's do a M666 space L. These are the settings that I ended up using. C height is 353.2. Diagonal rod length is 253.39. Delta radius 125.13. See, there's some auto corrections there. Now the Z height is probably off a tiny bit because I always have to go back and adjust it, so I could adjust those numbers, but so far that's what I've got. So we'll go from there. Alright, well there you go everybody. I'm actually currently still probing in the background over there, but where is it? Yeah, right there. Anyway, so one thing I wanted to tell you and make sure you know is if you use the printer face to move the print head around to check your calibration, you'll find out that it is not a good idea. I've never been able to use printer face to move the print head around and actually see that it's level. So I actually have to run a print test and check it that way. So keep that in mind. Maybe it's different for you, but it has not been for me. So now I spent like basically a whole day trying to calibrate this thing, and it's all time-lapsed. So enjoy that footage, and I'll see you in the next video where I'm actually replacing the extruder. So see you soon. It's actually backwards in time. I already did it according to filming this, but anyway, peace and love. God bless you guys. Have a good day. Thanks for watching.